An integral is the reverse of derivative. So when you are deriving something, you will have something like so. You must make sure before you integrate, you have to find this one on the trig identity, trigonometry, trig ratios. This means it's derived from this one. So we have to check this one, that is it derived from this one. Then if it's not, then we have to expand it and do the trig ratio. So in this case, you know that this one is derived from this one. So for you don't include this one, you just cut it off, and then you take it as we have only this one, and then you just integrate this one. So when you check most of the example, they are like that. So we have to know which one is from which one we are looking at. So because you'll find that you find yourself confused because of this one. So if you're not using a U substitution, just check which one is derived from which one. So if this one is derived from this one, then you eliminate this one, just you take it as you have this one, integrate it like this one. Like for instance, if you have something like this, and then when you derive this one, but because x, the derivative of x is 1, then you multiply by 1. But normally we don't show this one, but this is our f of x prime in this case. So this is f of x. So when you integrate, you have to check this one, whether one of this is the derivative of the other one or not. So when you find that this one is a derivative, you just eliminate this one on trig, and then we just integrate as you have only this one. So that's you'll be doing on the trig. So as you can see, they just ignore this one, and then they just integrate this one on this one. So it's what they are doing here. So if you find that you don't have you just have f of x, and then you don't have f of x prime, like this one, you have to expand it according to this, like the same way as they did. You see here, they expand it, and then they also expand this one. So when you have a square, like we have to make it an even here in order for you to find the other one. So if it's an odd is a number that you cannot divide by 2, and it will give you a remainder if you divide by 2. Okay, and then we have to find this one. So you break it the way they break it. So this one is like exponential is still the same thing, because if you add this one, it will give you this, and then we change this one using identity. The point of doing this is just you have to make f of x prime. So as you can see from this one, let's look at this one. This is a f of x prime. So just looking at this one, you can just integrate it. But if you don't find f of x prime, then we have to create one from. So you can just integrate this one, as you can see from here. This is integrate from this one, but this one they never include it here. Why? Because they know that it's coming from this. When you derive something, you will get this one and this one. So the derivative, you will have two pairs. You will have f of x and f of x prime when you're deriving. So when you integrate, you have to look for this one. So if it's not there, then you have to create one in such a way that you can able to integrate it. Like here we have this one as f of x, and this one as f of x prime, and this one as f of x. So you can eliminate this one and integrate this one. So this is what they are doing here. So this one we have there, we have it on a table, you can just integrate. So my concentration is on this one. Basically I'm looking at this one. Then we can see from here, you just have to create f of x prime if you're not using any substitution. So this one you can get it from the table. If you cannot get it from the table, then you have to find it. So in this case, you see this one is your f of x prime. You have to eliminate it. You see from here they never include this one here, so just take note that you have to have f of x and f of x prime in your integral on a trig. If it's not in the table like this one, you have to have your f of f prime. Same applies here. You have to find your sign here in order for you to integrate. So make sure that this one is odd. See here, it's an odd. Then multiply everything by your f of x prime. F of x prime means derivative. That's what you'll be doing, and then you will eliminate the, you see from here there is no cos anyway, it's only sign, representing that this one is in the table. That's why they didn't put it. So for this one it's not in the table, so this one is your f of x prime. So you will eliminate it, then integrate this. Also here same. Okay, this one you have to break the smallest one like this, but you always have to have your f of x what prime, and then multiply everything. This is your f of x prime. So you see, just eliminate this one and then integrate as there's none. This one you see here, there's 8, 5. So that's what you'll be doing on your integral. You check that it's in the table. If it's not in the table,